Hello folks, Mr. Green Pump here. How in the world are you? And welcome to video number 10. I have heard and read articles about heat from compressed air causing an increase in temperature of the nutrient solution, which this reduces the oxygen holding capacity. I want to solve this problem. I conducted 4 tests of my equipment during the winter, as I would need to remove all of the equipment to show you what I have done. The way I produce a video is to write out all information and simply read it. I do this for several reasons. I can put things in an understandable, logical order and can be sure that I don't leave anything out. In order to obtain accurate temperature readings, I am using a handheld laser thermometer to measure the pump temperature, and a probe type cooking thermometer to measure the air coming out of the air hose, and also I use it for water and room temperatures. To avoid confusion, I will refer to the ambient room temperature as room temperature and the air coming out of the air hose as the hose temperature. All readings are in Fahrenheit. The air pump I use is an O2 brand and is one of the largest at 1,748 gallons per hour. I have used this pump for 3 years and it works fine. In test number 1, I use only the air pump and a hose, which is what most people currently have set up. The room temperature stayed the same at 65 degrees throughout test 1. It only took 30 minutes for the hose temp to hit 100 degrees. And at that time, the pump temperature was 114. After 1 hour, the hose temp was 110 with a pump temp of 129. After 2 hours, the hose temp was 112 with a pump temp of 134. I can see where this would be a problem in the nutrient tank. In test number 2, I attempt to fix this problem by adding a cooling fan to the pump. Does it make sense that if you reduce the pump temperature, you could also reduce the hose temperature? The fan I use is a Holmes brand, all metal, mini high velocity personal fan with 4-inch blades. It can be purchased at Amazon for about $14. Place the fan about 4 inches from the side of the air pump and centered on the cooling fans. In test number 2, the room temp stayed fairly constant at 65 degrees throughout the test. After 30 minutes, the hose temp was 86 degrees and the pump temp is 85. After 1 hour, the hose temp was 89 and the pump temp was 90. After 2 hours, the hose temp was 88 and the pump temp was 90. What can we learn from test number 2 as compared to test number 1? Both the pump temp and hose temp reduced by more than half over the room temperature. Also, a cooler pump might mean a longer pump life. In test number 3, I did something different. Most hydroponic growers have 2 water tanks, one to hold reverse osmosis water and the other for nutrient solution. We are going to build a heat exchanger and use it in the reverse osmosis water tank to supply air to the nutrient tank. To start with, you need to convert your air line to 1/2 inch inside diameter hose. 1/2 inch garden hose will work fine. This heat exchanger requires 10 feet of 3/8 inch inside diameter by 1/2 inch outside diameter copper tubing, which is type L. It comes in a square, thin box. As a single layer spiral wound roll. Make sure it is type L, and you can find it at Lowe's for around $20. Avoid eBay sellers who are selling a utility grade, which is much thinner, for the same price. Next, take a milk crate and cut off the bottom 2 inches. Place the tubing spiral inside the bottom and spread the copper line to allow for 1/2 inch spacing or more between each coil. Next, take about 3 inches of each end and bend up so hoses can be attached. Take some cable ties and secure copper tubing to floor of crate. Do not use copper tubing smaller than this, as it will speed up the airflow and result in less cooling. For test number 3, I will use the heat exchanger in the water tank, and I will not use the fan so that I can see how well the heat exchanger works by itself. The room temp at start of test was 55 degrees, and at the end of the test it was 54 degrees. So after 30 minutes, the hose temp was 56 degrees and the pump temp was 105. After 1 hour, the hose temp was 56 degrees and the pump temp was 114. After 2 hours, the hose temp was 56 degrees and the pump temp was 119. After 3 hours, the hose temp reached 57 with a pump temp of 125 degrees. The water temperature at start of test was 50, and at the end of the test it was 51 degrees. So what can we learn from test 3? The heat exchanger did a very good job of reducing the hose temp by itself, but didn't get the hose temp down to the level of the room temperature. Most of the time, the water temp will be lower than the room temperature. In test number 4, what do you think the result will be when we use both the fan and heat exchanger? At the start of this test, the room temp was 63 degrees and the water temp was 51. During this test, the sun came out and heated up the greenhouse. Here are the results. After 30 minutes, the room temperature was 68 and the hose temp was 65. After 1 hour, the room temp was 75 and the hose temp was 67. After 2 hours, the room temp was 80 degrees and the hose temp 69 degrees. After 3 hours, the room temp was 80 degrees and the hose temp was 70 degrees. What can we learn from test number 4? By using both the fan and heat exchanger, the hose temp is kept below the room temp. In fact, at no point in time did the hose temp rise above the room temp, and at one point was 11 degrees cooler. The results of these tests I consider a success. If you have any questions or comments, please leave them below and I will try to answer them. And now, in closing, I have for you the quotation of the video. It is from Curly of the Three Stooges. If at first you don't succeed, keep on sucking till you do succeed. Thank you, and have a good day.